This video is going over question 27 of compiler sample exam. This video will not show the exam paper as it's copyrighted, so I will have a link in the description which will link to the 2020 exam paper. I will also look into the the MCQ exam of 2020. I might have misspoken, but yeah, so we have the sample exam and then the 2020 exam. And basically I'm going to do the parse trees. So for the exam we got from John Waldron, he gave us question 27, which was a graph. And that graph can be computed using stack remaining elements and actions. So I will begin with having a stack and remaining elements and actions. Then for question 27, we have some flex commands. So plus, return plus, minus, return minus, all of that. We had Bison code from 0 to 5. And we have a 22 mark. So that's a 22 mark question with inputs G equals A plus B plus backslash N. So this is what we have. So line 0 of Bison says we accept. And then this is our input, and then we end. So if you look at the graph at state 0, we take an action, and we have, so basically, sorry, the beginning part is a little confusing because there's nothing on the stack. This just says go to state 0, so go to the top of the graph, so you'll always be at state 0 no matter what, right? So this says we took state 0, and now we put except on top of the stack. So now from state 0 we have a look and we say, okay, state 0, we can, with an ID with G, we can go to state 1. Fair enough. So state 1, we took state 1 and we took the ID. Then from state 1, we look at state 1, we say, okay, what do we see? Oh, the token we have is assign now. So from state 1, we go to state 4 with an assign. So assign has been taken. Then we have an ID. So from state 4 to state 7, we have an ID. So 7 with A. And then we have a reduction rule, so R5. So we look at the Bison code, we look at line 5, which says ID. So replace, not replace, sorry, but basically it says delete the ID. So ID has been deleted. And then we have to decide where we want to go. Okay, so that's deleted. And then we have to decide where we want to go. Okay, so we just deleted line 5, not line 5, ID, which is rule 5, reduce 5. And that's a part of the expression function. So we look at what's on top of the stack right now. So 4. So now we look at the graph at state 4. And we just look at the reduction we've done. So we did the reduction on expression. So that means we'll end up at state 8. So go to state 8 on expression. And therefore 8 expression. And then from state 8, we see a plus. So we go to state 9. 9 plus. From state 9, we see an ID, which is B. So we go to state 11. And then we have a reduction rule, which is reduction rule number 3. And reduction rule number 3. So we look at line 3, it says expression plus ID. Okay. So we can see here we have expression plus ID. So when we execute rule 3, we delete that. And then we have to decide where we want to go. So we want to go to state. Let's see. What's on top of the stack? 4. We just did an expression rule. Therefore, from state 4 with an expression rule, so the dotted arrow tells us that we did a reduction. And the top of the stack says, from state 4, do the reduction arrow. And we did the reduction arrow on expression because we executed line 3 of the Bison code. Therefore, we will end up at state 8 again on expression. Sorry. And we'll just say that. And we wrote this and that because the reduction, it doesn't actually delete it. It basically breaks down the computation. So you could imagine in assignments what the reduction was doing was it was doing like 1 plus 2, like $1 plus $2 in our code. So it's reducing and it's just like computing the answers for us. So this is like an answer, which is A plus B, right? So from state 8, we see that there's a plus. So we say, okay, go to state 9. 9 with a plus, delete that. And then we say, okay, there's an ID. An ID is only accepted from state 9, which means we error out here. And therefore, our answer is, so we look at all the actions we've done, right? And we do not count reductions as actions. We count G's and S's. So 0, 1, 4, 7, 8, 9, 11, 8, 9 is our answer. Like so. Okay. I will also go over 2020 exam, which I will also link in the description. And what I'm going to do is I'm going to do section D.1, where we will have to parse. What will we have to parse? Give me a second. This. So every question starts like this, and whatever inputs here. So basically that means every answer is going to be starting with 0. Okay. Let me fix that. There you go. And then that means that we accept and we begin, basically. This is the boilerplate. So now we begin. So we have basically the same structure. So we find that we have an ID from state 0. So we go to state 1. 1 with an ID has been executed. Then from state 1, we see that there's an assign. So from state, so we want to execute state 4 with an assign. And then we've executed state 4 with an assign now. Then what we want to do is we want to execute state 7 because we see that there's an ID. Now we execute state 7. Then what do we want to do? Oh, we see that there's a reduction rule. So we'll go to line 5. Line 5 says ID. So this is an ID, so that gets deleted. And then we have to decide where we want to go. We look at the top of the stack, 4, which means we go to state 4. We deleted a part of the expression reduction. So 4 with the dotted arrow expression, we end up at, let me just zoom in, state 8. So go to state 8 on expression. 8 on expression. Right? Then we have to decide where we want to go. We see that there's a plus, so we want to do S9, because S9 says, state 9 says, from state 8 to S9 we have a plus. So that's exactly what we're going to do. So we delete that. Then we see that there's an ID. So from state 9 to state 11, that there's an ID. Okay. And then there's a reduction rule. So we do the reduction rule 3. So we look at line 3. Line 3 says expression plus ID. So expression plus ID That goes away. And then we decide where we want to go. So we look at the top of a stack, state 4. Then we see, okay, state 4, we did an expression. So we did line 3 a part of expression. Therefore, we will end up at state 8 following the dotted arrow from state 4 with an expression. So state 8 on expression. Which means that gets computed down to expression. Great. We see that there's a minus, which means from state 8 we show up to state 10. 10 with a minus. And then we see an ID, so we'll go to state 12. Okay. Then we have a reduction rule. Our reduction rule is reduction rule 4, which means expression minus ID. So we do the reduction rule, expression minus ID gets deleted. Then we have to decide where we want to go. We look at the top of a stack. We see we have 4. From state 4, we did the expression rule. Therefore, 4 dotted arrow expression, we end up at state 8. Rinse and repeat, it's a very similar structure. Sorry, go to 8 on expression. Then we have expression. And then, because there isn't a plus or a minus, we will go to the reduction rule where it matches no tokens. So R2. And R2 says, that an ID assign expression. So ID deleted, assign deleted, expression deleted. We have to decide where to go. Well, we look at the top of the stack. This time it changed 0. So we look at state 0. We just executed R2. Therefore, we executed statement function. So from state 0, follow the dotted arrow that says statement. So we'll end up at 3 on statement. 3 statement. Perfect. Then end of line is the \n. So from state 3, we'll end up at state 6 with a \n. That gets executed. \n. Then we have reduction rule. The reduction rule is line 1. So statement end of line. Statement end of line gets deleted. Where do we want to go? We want to go with state 0, which is on top of our stack. We executed line 1, which is S. So follow state 0, dotted arrow S, state 2. So go on S. S. Sorry, not S, it's 2S. And we see that there's an end from state 2 to state 5. So we want to go to state 5. And that has an end, like so. And we accept, because the end is gone here. There you go. So let me zoom out. So again, the answer is going to be everything except the reduce rule. So 0, state 1, 4, 7, 8, 9, 11, 8, 10, 12, 8, 3, 6, 2, 5. So 0, 1, 4, 7, 8, 9, 11, 8, 10, 12, 8, 3, 6, 2, 5. And then let me just double check. Compared to the correct value I had previous. This was not the one, sorry, apologies. Let me just get the value that I had for this answer myself. Oh, and it matches, so I was right. Okay, perfect. And then I'll go over D.2, which is a graph again. And what we want to compute is this. So we have this boilerplate pretty much. We have to compute a equals minus 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 c, new line, s0. Then we have, so we executed s0, we have except on top of the stack. And a equals that. And we go to statement 1 with an ID. So we get this. Then we have statement 4 with an assign. So we get this. Then we get from 4, where can we go? We can go to statement 8 with a minus. So we have a minus. So we go to state 8. Then we see that there it's a it's not recursive. It's the arrow is basically pointing to the same state. So we do that 2 more times, like so. Like this. Then there aren't any minuses. We see that there's a C. So with an ID, it's going to go to state 7. Which is this. So an ID with state 7. Then we have a reduce 6 rule, which means what happens is we delete that. We have to decide where to go. Well, on top of our stack, we have 8, which means we will look at state 8 and see that we executed line 6, which is a part of unary, so we will end up at state 11 on unary. Which means we'll have this. And then what happens is we end up with a reduce 5. And reduce 5 says line 5 minus unary. So minus unary gets deleted. And then we have to decide where to go. Well, what's on top of the stack? We have 8 on top of the stack. Therefore, we will do the same exact thing. We will go to statement 8. We'll see that we executed line 5, which is a part of the unary function, which will say state 8 unary state 11. And then what will happen is we will do that again and again and again until all of our minuses have been taken care of. Like nearly like this. Reduce 5. There you go. And instead of looking at instead of going to G11, we look at the top of our stack and we say, oh, it's not G11 because 8 isn't on top of our stack anymore. 4 is on top of our stack. So from 4, we did, what did we do? We did the reduce 5 rule. So we did the unary rule. So state 4 with the dotted unary arrow will end up in state 10. So that's why we go to state 10. So therefore, 10 unary. And then we will see, okay, do we have power? No. So therefore, we will reduce using the reduce 4. And what does reduce 4 tell us? Well, if we go to line 4, it says unary. So we delete unary. And then we have to look on top of our stack. And on top of our stack, we have 4. And then instead of ending up where we were, because on top of our stack is 4, and we did rule 4, which is a part of the expression function, therefore From state 4, we follow the the dashed expression arrow to state 9. So G9 on expression, which means 9 expression. Now, we will have a reduction, which will say rule 2. Rule 2 says ID assign expression. So that's ID assign expression. We decide where to go. Well, on top of our stack is 0. So we look at state 0. We just did line 2, which means we did statement. So from state 0 with statement makes us go to state 3 on, and we executed statement. We have 3 statement. And then from state 3, we have an end of line with state 6. That's fine. 6 end of line. And we do a reduction 1. Which means reduction 1. And reduction 1 has statement end of line, so we delete that. We just did line 1, so we did S. On top of a stack is 0. State 0 with S makes us go to state 2 on S. So 2S. Then we have a $end, so from 2 to 6 with a $end. 6 end, and it's accepting. So perfect. So our answer will be 0, 1, 4, 8, 8, 8, 8, 7, 11, 11, 11, 11, 11, 10, 9, 3, 6, 2, 6. Sorry, the last one isn't 6. My bad. The last one is 5. I just misread. From state 2 to state 5 with $end. And that's correct. Yeah. So that's the answer to D.2. And that's how you do these questions. So the main thing is when we do a reduction, we remove the thing we're reducing. We look on top of the stack to make sure that we follow the correct dashed arrow, because there may be multiple dashed arrows in the question. And we follow the dashed arrow of the thing we just deleted, so the rule we deleted on the function. And that's how you do these questions. Thank you.